Welcome to Physics in 5 Minutes, where I give you answers that you might actually be able to understand in just 5 minutes. And today we're talking about light. So what is light? What's that thing coming out of the light bulb? Is it a particle? Is it a wave? Is it here or there? Okay, let me straighten this out for you, okay? Light is strictly a wave, okay? Now, if you watched my previous videos on what space is, I say that space is made out of material medium, and it's basically a sea of neutrons. So the first question to ask is, if light is a wave, what is it waving in? It is waving in this neutron sea. But obviously light is not quite the same thing as, say, a sound wave. But in some ways it is. It's just a compress in rarefication of the medium, and that is how it's transmitting its information. It is never a particular particle traveling from point A to point B. So to explain some of the differences between, say, sound waves and light waves, I have my picture here, okay? Now, I explained that space is quantized in that it acts like a Lego brick plate, and if you have, say, an electron, it can only move into like this grid pattern here. So when we are having light generated by, say, light bulb in visible range, we have an atom, and these electrons are attracted to the atom, and they are falling down, and they finally hit the atom. Now, when they hit the atom, they emit what I'm calling a quantum wave cycle, which is basically like a single cycle of a wave, just up, down, that's it, just boop. And if it hits from further away, it's going to have just a higher frequency. But it is a wave, but it's the kind of wave like, this is what's called a Newton's cradle device. I don't know if you've seen it, but there's like 5 balls. And it's like you lift up one ball, and it goes and it hits the other balls, but you don't see these moving. But the wave travels through these in a straight line in a very tight packet with this quantum wave cycle. And when it gets to the end, it ejects the ball at the end, like that. So that is basically how light travels. That's different than sound waves. And it's the reason why some people think that light is a particle, because when it travels like this, it contains a fixed amount of energy. It travels in a straight line. It doesn't disperse like regular sound waves would. But a kind of wave which does do that exactly are radio waves. Now, radio waves are different. Radio waves do not depend upon this electron falling around an atom type of situation. What we have in a radio transmitter is much more similar to sound waves, where we have like a device which is pushing electrons out of a transmitter, and then that is just impressing upon the surrounding medium a compression wave, which is like what I've depicted here, which is spreading out in like a circular pattern. And these kind of waves can have variable amplitude and act very, very much like sound waves. So that is my simple explanation to remove all the confusion around what light is and compare it against, say, radio waves. And why is it that our light waves seem to have particle properties? And yeah, they look like particles because they contain only a fixed amount of information. They take a finite amount of space. They travel in straight lines. And, you know, most people say if it looks like a duck, quacks like a duck, it is a duck. But in this case, it's not. So I hope I've cleared up what light is. And once again, these are my personal opinions. And if you disagree, then please comment below. And please also read my papers. You can go to franklinwho.com and read about all of the basic principles which I describe in my videos. Until then, ta-ta!